Hello. In this video, we're going to start looking at some special logarithms. Okay, so the first special logarithm that we want to look at is called the common logarithm. So the common logarithm has a base of 10. Okay, now it's written as log of some number. Now notice that there is no base there. When you have log written without a base, that's assumed to be base 10. So that number right here that we're missing is actually 10. So if we said log of 3, that's actually log base 10 of 3. Now we do have to be a little bit careful. If you're reading in a textbook, every now and then, especially older texts or specialized texts, just use log instead of ln for natural log. But generally speaking, this log for us will always be base 10. So if you want to, you can always just write down with a 10 right there. So now we want to look at the natural logarithm. The natural logarithm has a base of e. Now this is important because e is a very important number. Now, and it's written not as NL, which what some people might think of for natural logarithm, but it's actually written as ln. Now the reason we write it as ln, and it's pronounced ln, the reason that we write it as ln, first of all, we like to use L for logarithms first, and the reason we can use ln here is because we actually got this from the French word logarithm naturel, and it was really the French that kind of developed this. Alrighty, and yeah, just so you can see it, I think it was logarithm. I don't remember if there's an E on the end or not for the French. Naturel. There we go. So ln produces this. So ln of 3 would actually be the same thing as log base e of 3. We like to use ln because frankly it's quicker and we use it quite a bit. Now we want to convert each of these exponentials to logarithmics or logarithmics to exponential expressions. So on a here we have 10 to the negative 2 equals 1 over 100. Notice that the base is 10. That means we can use the common logarithm and just write down log of something equals something. There's an understood 10 there, so I don't need to write it. Now the exponent, negative 2, is always by itself, and that means that the, what I have not used here, this one, the 1 over 100, will go right there. So log of 1 over 100 is negative 2. B, e to the third equals the cube root of e. Okay, so notice that we have a base of e here. So since we have a base of e, what that tells me is that we need to use ln. ln of something equals something. The exponent is 1/3 on the base there, so the natural log of something equals 1/3, and that means that whatever's left over here is going to be the argument, so it's going to be the cube root of e. So the natural log of the cube root of e is 1/3. Good. Now notice that we're starting with logarithms, and we have ln, so natural log of 1 over e equals negative 1. Well, with ln, that's a base of e, so it makes that e to this power, negative 1, is equal to the argument, which is 1 over e. Good. And now for letter D, we have log of 1 equals 0. And notice that no matter what, as long as the argument's 1, it's always equal to 0. In this case, though, the base is understood to be 10 to the 0th power is equal to the argument 1. Awesome. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.